Let's take a look at another example from section 5.5 involving a double angle formula. Number 8 out of your book has solving for tangent of 2x minus cotangent of x equals 0. And we're going to solve it on the interval 0 to 2 pi. So we're going to have a finite number of solutions for this problem. Now again, the first thing you need to recognize here is that you have a 2x and a x. We can't solve for x if there's a 2x and an x, so we need to start by applying the double angle formula for tangent of 2x. So let's start by rewriting that. That's going to become 2 tangent of x over 1 minus tangent squared x. And then let's move the cotangent of x over to the other side of the equation. So the equation now becomes 2 tangent x over 1 minus tangent squared x equals cotangent of x. Now, we've got this fraction on the left-hand side. Let's see if we can't work with that. Now again, we want to be careful anytime we try to eliminate a fraction that we're not eliminating a trig function from either side. And we're going to be okay with that here. So I'm going to multiply both sides by 1 minus tangent squared x. And so on the left-hand side, again, those are going to cancel, so I'm going to be left with 2 tangent of x is equal to, and on this side, I want to go ahead and distribute that through. So that's going to become cotangent x minus a cotangent x times a tangent squared x. Okay, so let's see what else we can look at here. Well, I think we can actually simplify a little bit. If we look at this term right here, there's a cotangent x and 2 tangent x's. Again, one of the tangent x's will cancel with the cotangent of x. So let's take a look at that next. That's going to give us 2 tangent x is equal to cotangent x minus, and we're going to be left with 1 tangent of x. So now let's bring things back together again. If I add tangent x to both sides, I'm going to end up here now with 3 tangent x on the left-hand side, and 3 tangent x is equal to cotangent of x. Now I don't want to divide here because that's just going to create a really big fraction over here, and I might run the risk of losing a trig function and a possible solution here. So let's bring the cotangent x back over to the other side and set everything equal to 0. Now when I do that, remember that cotangent of x I can write as 1 over tangent x. So I'm going to rewrite it so everything is in terms of tangents. Okay, so let's see what I can do now. Well, what if I combine these two? Again, I can think of this as 3 tangent x over 1. So if I get a common denominator, this is going to become 3 tangent squared x minus 1 all over tangent x, which is equal to 0. Now I'm able to do some factoring, and that's going to help me solve this particular equation. Now this is a little bit different factoring than you might have looked at, but this denominator now, I can separate that fraction out, and I can rewrite this as 1 over tangent x times 3 tangent squared x minus 1. And this is now going to allow me to apply the zero factor property. 1 over tangent of x is cotangent of x, so I want to know when is that going to equal 0. And then I also want to look at when does 3 tangent squared x minus 1 equals 0. And now I'll be able to find all of my solutions. Now cotangent of x equals 0, that's only going to happen when cosine of x is equal to 0. So if we think about our unit circle and we think about when is cosine actually equal to 0, that's going to happen at pi over 2 and 3 pi over 2. So for cotangent of x equals 0, that's going to happen when x is equal to pi over 2 and 3 pi over 2. So we have two solutions for that part of the equation. Now for the other part, let's isolate our tangent squared x. That's going to give me tangent squared x is equal, bring the 1 over, that's 1 over 3. And so now if I take the square root of both sides, I need to remember that when I come out with my tangent x, it's equal to plus or minus 1 over root 3. Well, that looks like a value from one of my known angles. So if again I double check my triangle, pi over 6, pi over 3, 1, root 3, and 2, pi over 6 is opposite over adjacent, so my reference angle here is going to be pi over 6. Now the plus or minus is actually going to put me in all four quadrants, because again for my pluses I'd be in the first and third quadrants, for my minuses I'll be in the second and the fourth. So I'm going to have pi over 6 in all four quadrants. So I use my reference angle for the tangent of x. I'm going to get x equals pi over 6 in the first quadrant. In the second quadrant, I'm going to have 5 pi over 6. In the third quadrant, 7 pi over 6. And in the fourth quadrant, that's going to give me 11 pi over 6. So for this problem, I have 6 solutions. Pi over 2, 3 pi over 2, and also pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6.